This conference will now be recorded.
Right. So MongoDB accepts the data in JSON format and BSON format, in both the formats, but it writes the data. Even if you are submitting the data in the JSON format, it converts the data into BSON format. So MongoDB only understand the hardware understand the BSON data only, not the JSON data that we have already seen. Quickly see, if I have to load some data, we always supply the JSON data. Generally, we enter. So giving the BSON data is an extra effort to the developer. Why? Because he has to give the quotations to the keys also. What exactly I mean? So example, db.test, do I have how many, what collections we have? Let's see where we connected first. So how do we check where we connected? Just a db, enter db, it will tell you what database you are connected to. And if you wanted to see all databases, show dbs. This will show you all databases currently created on the Mongo. If I wanted to switch it to one of the particular database, use the database, just use the database and then paste it. So generally don't type in the real world. MongoDB is something, if you by mistake type a wrong letter, it will create the database. And you execute a query, it will create the data on the fly on that database. So I don't recommend, or I don't type the database names in the in my project. When I do work on the live, just select the database and it will get copied. Anywhere you click it, that's fine. Shift insert. Though that is will not make you to not to create any unnecessary issues basically, because Mongo is something, it does not require any extra parameter to create database. Use database is enough. It will create the empty database. If you run some command under it, maybe it's some insertion, something like that, it will go and create the collection and insert the data that you did not real you don't realize, like you typed the wrong database name, data went into the different database name. So better to be very careful when you're picking up a database. Just highlight it and click it somewhere and shift insert. When you highlight, that itself will copy the database name. That's enough. So I'm using the database name, and then I wanted to see what are the collections we have. Collection means equivalent to table in the RDBMS that we have seen in the last. Means if you look at this chart, we discussed basically what is table called as collection in RDBMS, database called as database, row is called as a document here. Okay, column called as field. So here very quickly, I mean, just a recap, 5 minutes recap, not more than that. Show collections. Show collections. If you see, there are two collections. If I wanted to create a new collection, I can create manually, like create collection, or else I can, without creation also, if you just mention what you wanted, maybe lab insert. I'm inserting a data into the collection which is does not exist at the moment in the database. The syntax for loading any data into Mongo is first parenthesis, within the parenthesis flower brackets. Within the flower brackets, you mention whatever you wanted. So here I'm just keeping like T number and one T name. Just tell me like what kind of data it is, a JSON or BSON kind of. I'm just keeping here, okay, some data. So is it a JSON data or BSON data? Tell me.
JSON,
It's a JSON data. Why it is JSON data?
because the field is not in a quote.
Right. Field or key. We can say that field or key also. So this is a key value. This is a key. This is a value. This is a key. This is a value. The keys does not have the quotations. The keys does not have the quotations, and you're entering that data. This is called a JSON data. But always system only understand the BSON data. It will accept the JSON data, but converts into BSON. At the end, hardware, the physical storage only knows the BSON data, not the JSON data. So when you're entered, Mongo is responsible to convert that into BSON and load into the hardware, into the physical drives. So when you're reading that data again, that will be converted into BSON that we already discussed. Just quick recap. If you see the key value, key or field, both are correct. What Biren said is field, that is also correct. Key also is fine. Key will be appended with the quotations. The quotations itself is called as BSON data. Anyway, value you must supply the quotations if it is a string. If it is a number, even it is a BSON data, for numbers it won't append the quotations. It is just a number, means number only, it does not have the quotes. If it is under quotes, it is a string. It will be considered as a string basically. We're going to talk about the data types in Mongo in detail about it. The topic is get to be covered in the future sessions. But for now, try to understand numbers does not have the quotes, only strings will have the quotes basically. So this is called a BSON data. So MongoDB directly, if example, if I'm submitting the BSON data directly, it will take. It's you're reducing the effort to the Mongo to not to convert the data. So you can directly come on. I'm giving the quotes to the keys also, which means that I'm entering the data in the BSON format. It accepts. Some fields are BSON format, some fields are JSON format. That combination also will accept that we have seen in the last class. So any format data will be picked up, either JSON format or BSON format. And there will be syntactical errors anyway. Syntax you must follow. Without syntax, you cannot load the data. Syntax and all, I'll talk about in the future sessions. For now, this is what we discussed, guys. What is the ID field? Also, we discussed how it is going to help us, what it is giving us, what data it is giving us. We discussed about the ID field also. Let's move on further from that class. So right, so we discussed about the database as well, guys. A collection is a group of related documents. Generally, a collection should have a related documents, not the unrelated document. Example, you're running different businesses. Anything like, if you're keeping student data, keep the student data only in one collection. Don't mix the teacher's data. Just example, you have a student department and the teachers department. They do different, their departments are different, right? You maintain the student data separately and teachers data separately, but you don't club the student and teachers data into one collection. That is called related data means basically. Don't join the unrelated data into one single collection. Why? Because you have to add more filters to find actual data. When the data is messed up, if it is not segregated, it is tough to retrieve as well with logical conditions. That should not happen. You definitely have to keep the data of which is related in a single document, single collection. Collection is equivalent to table. Collections are schema free. Schema free we discussed, guys. This was since the beginning I was talking about. Collection always does not depend on the table design. There is no design. You just, it is creating the collection on the fly, and it is taking n number of fields you can give in each document. There is no restriction. There is no schema restriction. It is takes any data in any format. It is accepted. If I go and read lab.find, we discussed this many times. So this actually have extra field. I did not define this phone number anywhere. So you don't need to define in Mongo. Every field, every document is an independent structure. One document is having this structure, other document can have any structure. There is no defined structure for you. It can pick up any data basically. So that is called schema free. You don't need to define the schema and load the data. Schema is a dynamic. Whatever the fields you load into Mongo, it will pick up. It does not matter what format you are pushing the data to Mongo. That is what about the schema free. Keeping the different kinds of documents in the same collection can be nightmare for developers. Like you're keeping example teachers data and students data, and you wanted to filter out the data. It will become very tough, right? You cannot just find the teacher or student with the name. It is not possible. There should be some extra identity which we need to give to student and teacher to identify separately. So why you are keeping the data together and messing up things? Just keep it separately so that it easy to for sorting out and pulling the reports. That's what it is saying, that keep the different data in different collection. Don't club the unrelated data into one single collection. That something is very important. What the heck? How to join the class? Just a minute, guys. Who's this? Karthik. Use this. Just a minute, guys. Use the same link. Wait. Karthik did not join. Just a minute, guys. Sorry for the interruption. Karthik is joined. Oh, who is this Karthik? Okay, fine. Right. So grouping documents of the same kind together in the collection allows for the data locality, so that if you keep the data together which is related, it is easy for you to pull out the data out of it. MongoDB groups collections into database, right? In a single database, will have a lot of collections. Each collection can grow up to 32 TB. single collection. See, you have a database called where we connected to right now, SQLDB, and we created show collections. Show collections, how many collections we have? Each single collection can grow up to 32 TB. 32 TB is not a small, we are talking about very vast data, and it cannot scale with a standalone. You definitely do the sharding. If the database is going in terabytes, you definitely have to do the sharding to get the scaling power, the performance power that we discussed anyway. Okay, we discussed anyway about it, right? So sharding, what is the sharding? How it? I mean, just I given an introduction. I did not complete it yet. We have a separate module. So sharding, there I'll pick up the point again. A single instance of MongoDB can host several databases. There is no limitation of databases. You can create n number of databases, each of which can host completely independent data. See, one more thing, guys. Another big thing is, if you are doing example, you have a lot of different businesses, like you do the transport business, you do the schools business, you do different business. So for each application whatever you do, you need to separate the data. School's data should be school only, transport data should be transport only. Don't keep the data into, like schools and transport data, you don't keep in a single database. Keep it, because you're running a school, you also need transport, like getting the students and like dropping the students, all that. You have separate department for that. You have to keep it separately. Their data in, like how many people came, how many people did not attend, something, whatever it is. So don't keep the data like club with the one department of data to other department data. Keep the data in a different databases also when you're handling with a different altogether different business. Basically, that makes things easy for the developer to call database wise. See, transport, they'll call directly transport. So transport related collections all will be under transport database. If it is a school, means school, teachers, department, all will be in a single database. So you have to keep things separate when you're doing the business. Don't club everything in a single database as well. Not only collection level, database level also. You need to look at the structure and architectures. Good rule of thumb is to store all the data for a single collection in a same database. Right. So what it is, single application. So what it is saying is, you have one application. Okay, try to keep the data in one database, and if you can keep two databases. See, this is something, let me tell you, this architecture, you follow, you don't follow, Mongo will take the data, but best standard says this. Let me quickly conclude this point. You have four databases, okay, and the three applications you have, assume a case. One application should load into one database only. Basically, if required, it can go to two databases also, but these two databases are already given to application one. Okay, it is A2, second application, this is A3. The rule of thumb for this one is, if A1 is using two databases, don't use A2 applications data into any of these databases anymore, because they are reserved for the first application. So if a different application, keep the different database itself. Don't mix with the existing databases application data. And one database can go with the multiple databases, but one database should not mix the other databases application data. You confused, or you got the point? Let's let me know. One application can go to multiple databases if required, because subdivision is there within the application, within one business. Divisions, there will be divisions. That is the reason they occupying two databases. One D1 database one, D2 are occupied for the A1 application, D3, D4. So when you occupied two databases, one for one application, second application should not mix with the other applications databases. That is a rule basically in Mongo. We keep that way. This is a design, guys. It's a recommended design. However you load the data, Mongo does not reject. That is there. But you have to be very careful that to segregate the data. If you don't segregate the data properly, there will be an impact for sure. There will be an impact. Why? Because when you keep unrelated data, that will be a problem. Obviously, problem on the system. That should not happen. So keep the each application as a separate database. Don't mix with the other databases where the other application is already using one of the database. Is that clear, everyone? Say something, please.
How about if
Is it?
one
Go ahead.
database, one database can be used by multiple applications, right?
Yes, multiple application. Oh, no. One database cannot be used by multiple applications. Should not use multiple applications in Mongo.
But yeah, if
One
my
one application can use multiple databases, which is good, but one application should not use the database which is used by other application. That is the point here.
if my business requirement is like in one database,
Hmm,
there are like multiple tables where
hmm.
three of the applications are using the same database. Then how about yeah, I know
Here
in
in
RDMS.
right.
Mhm.
Go ahead.
Yeah, in RDMS, like we generally have that, right? Like one database can be used by multiple applications, and of course, is vice versa as well. One
Right.
application is just like multiple databases.
Right. In Mongo, we have a relations basically. You can relate a table like you have a primary key and foreign key relationship. One table can sit in one database, other table can sit in another database and keep the relation and load the data. Here, there are no relations. Every document is an independent. One document does not have a relation with other document at all. So here there is no dependencies, in terms of collection to collection. When there is no difference, keep it a separate database and load the data there so that it will become easy for you to for the data retrievals basically. In RDBMS we have relations. Here we don't have relations at all. Everything should you have to keep the data in the locality only, local database only, local collection itself, local document itself. I'm going to talk about that right away after this slide anyway. So this is a rule of thumb you have to follow, because in RDBMS is different, NoSQL is different. We cannot combine. One application can use multiple databases, whereas one application, see, another application cannot use the database which is already used by the other application. It has to pick up the fresh database. That is a condition you need to follow.
So is it, I mean, it's a
Mhm.
mandatory or it's a good practice?
It is a good practice, not mandatory. Mongo will not reject you anything. You have to
Okay,
follow the certain good practices to get the better performance. It to become, if you design properly, the at the end result will be easy. Like, developers job will become easy. If you make it complex, it will become complex. So it's like that.
got it.
How you design, how you at the end you see the application architecture also. To list the databases, show database. To use the database, just use database name. You can switch it to that database. It's simple, right? We have seen these commands. To list the number of databases on Mongo, you just go and run show DBs. That's it. It will list you all the databases. If you wanted to switch it to specific database, just use the database and copy paste, and then you can enter into database. If you wanted to see the collection, just use the collections, number of collection that you have in the database. This is about this collections, guys. So MongoDB stores the documents in collections. Collections are analogous to tables in the relational database. Collection is exactly equivalent to a table in the RDBMS, basically, right? That we have discussed in the chart already, the RDBMS discussion, RDBMS and MongoDB comparison discussion. To create a collection, if a collection does not exist, MongoDB creates the collection when you first insert the data. See, db.collection.insert. If you do this, it will create the collection by default. It is not letting you to ask you first. It is not asking you to create a collection, insert data. It will create the collection and load the data if collection does not exist. That is what the sentence is saying altogether. The insert operation will create the respect to collection if they do not already exist. You don't have a collection name, it will create. To list the number of collections, see, this we have seen already. I discussed in the first demo itself. It will create a collection on the fly. That is what it is. To list the collections on the database, use the below command. Show collections will show you all the collections that the database is having. And if you wanted to know in which database you're reading the collection, just DB. DB will tell you to which database you are currently connected to at the moment, basically, right? That is what it is. So now, right, where are we? Let's go to the next one, documents. So document is basically holding all of your customer data. It can be, right? MongoDB stores data records in a BSON format that we have discussed, the BSON document. BSON is a binary representation of JSON document. So you are sending the data, key values will not have the quotations in the JSON format. BSON format, key values or field values will have the quotation. That's what it is. So BSON is a binary representation of JSON documents, though it contains more data types than the JSON. So basically BSON will allow few extra data types that we'll see. So maximum size of the single document, if you see, what is this size of this each document, the maximum can go up to 16 MB only. If your one document size going more than 16 MB, it will fail. See, you are entering the data single document cannot go up to 16 MB. I never seen anyway. But if example, if I'm loading a video, the video will load as a single document. So that cannot be handled with the JSON format. There is some separate service where we can handle the data which is not part of the grid. If there is something separate service we have to handle the data, like you have example video, okay, you have a PDF which is more than 16 MB. Non-editable data means videos, PDFs, photos, whatever it is, more than 16 MB. If you wanted to load into Mongo as a document, normal insert statement will not work. You have a separate service called GridFS. We are going to talk as a separate module. Whatever the data is more than 16 MB, Mongo will not accept through the query language. It uses separate service to load the data. That is called GridFS. GridFS will help us if the data is non-editable and more than 16 MB. We're going to talk about that. So sample document looks like this. So let me explain this one document, guys. How Mongo documents in the real world they fit into quickly. So I'll spend 10 minutes here. Just try to follow. I wanted to create a document which is going to have lot of different data. Assume like this about one single one person or one business entity, whatever it is. db dot example customer. I'm creating customer collection. Insert. So in insert, you have to go with the parenthesis. It's a minimum parenthesis. Let me take it in a proper format so that it is easy, guys. I'll make you understand. You can write your own scripting if you understand slowly. Okay. So this is parenthesis. Within the parenthesis, you need to have a minimum flower brackets. This is what is a minimum syntax for the Mongo, right? So now here I'm going to define what I want to define. This is a minimum syntax you have to follow. Parenthesis, within the parenthesis, flower brackets. Then maybe I'm entering the customer data, maybe like first name, assume a case. I'm keeping it is Karthik, first name, comma, first field, comma. And this first name is a key, this is a value. So value will go with the quotations as it is string. Maybe last name I'm keeping it, last L name, just for the sake. Last name I'll keep it, I don't know, so just I'll keep it L, whatever it is, just for the sake of discussion, as a is capital. And his gender, I mean the gender you also need to mention, right? Gender, let's keep it male, kind of. Gender also I'm mentioning in the application. This is an application. Maybe after that, address will have a lot of details. You'll have a street, you will have a like a first street, city, state, country, something like that. You will have a lot of data, so that will go inside the another document because it is not one parameter, it has more parameters, so it will go into different parameter, different document again altogether. So here I'll mention street. First street, you belong to maybe some colony. Maybe here we have OE colony something. Okay. And then after street, you need to definitely mention the city. Minimum it is, right? City, I'll call it as Hyderabad. Just an example. So how you can enter the data based on the data need. And after that, state you wanted, state. And after that, country. Right? If you understand this, you can write a lot of scripting. I'll tell you how to write. Okay. Then this is ended about here. Then keep the comma, that is over. Next, maybe is owning different accounts, maybe different phone numbers. Phone numbers, he has two phone numbers. When he has it two numbers or something like that, go with array representation. Okay, phones, maybe phone something, phone number, whatever it is, you keep it phone number. So maybe primary number something like this, comma, secondary number, and this is also different field. I'm going with array. Maybe account, he has a bank account kind of something, accounts maybe. So accounts also you can have different types of accounts, right? Savings account and a current account, something like that, and what is the salary is earning kind of information, if you have it, just for the sake of discussion. It's a numeric, it does not require something kind of is a example getting 70,000 in hand, something like this. So if you wanted to add some more details, more and more details about one person, you keep add it. Don't mix the Karthik details with the other document. Everything about the Karthik should go into one document only, so that data will kept as a locality to the single document. So about one entity information should go into one document only. You cannot keep in another document and join them. There is no join concept in Mongo. You keep adding the data about entity one after the other. Maybe you wanted to add in future also, you can add it to the same document by updating it. How do we update, how do we add the extra fields and data to the existing document? We're going to see that. But business runs this way in Mongo basically. Okay, if I go and insert this one, the last one don't need a comma, because if you wanted to declare something further, then go for the comma and then keep adding more and more fields and adding more and more values for it. It's like that. So I'm picking this data, going to Mongo, and where I am right now, MongoDB, wherever I am, doesn't matter. I'm just copy pasting. I'll run this. It was inserted one document. If you see this data, db.customer.find, it will give this data like this. But if you want it to read in a human readable format, like good format, there's something called pretty command. If you use this, data will load in much readable way, organized way. So you can see ID is an extra field which will append it to every document. That is we discussed. And you can see this data like this. Now I'll insert one more record quickly. I'll read out whatever the data you wanted very quickly. If you want it, I'll save this and send it across for your practice. Right. So I'll keep some record here, just as in my case. Information about here, maybe I'll keep it first name as Mahesh, and is capital is just M, and it belong to some Kukatpalli something. Just I'm giving some Hyderabad, Telangana, India is fine. And phone numbers are obviously different. Some random, sorry, it must be some random number I'm giving. I'll tell you how to read this. Just as I was talking about the document, you just need to understand what is the document means. Basically, that is the reason I'm just taking one example, letting you to understand. So maybe salary for him is a 90,000 something like that. So I'm inserting another document, another customer information, and loading it like this. So now if you go and read db.customer dot, okay, find, just this will read the data this format. I don't want that way. I want it in a more readable format. So pretty you have to use extra. So now you have the data like this. So now I wanted to filter the data further. It is so simple. How do I read an embedded document? Just if you wanted to read this document, it is simple, straightforward. db dot customer dot, we have separate module for CRUD operation. I'm just giving an introduction, don't worry about it. Find, in find you have to give the condition. Always everything will follow in Mongo, parenthesis, within the parenthesis flower bracket, within the flower bracket mention what you wanted. So what I wanted is f name I wanted Mahesh, that field I want, that record I wanted. You can even filter This is a case sensitive basically. Mongo, it is a case sensitive. If I use F and I'm using small f, it won't call it. So, sorry, pretty. Or I'll just see. It is not giving any record. We have f name Mahesh, but the field is a case sensitive. You must give the exactly what it is. Uppercase, uppercase, lowercase, lowercase. It is not a case insensitive, case sensitive. If I give it, I get the record like that. You're getting one particular record like this. If you wanted to get the particular embedded document, how do I read it? So the people who are belong to, maybe I wanted to read OU colony, whoever belonged to in OU colony in the complete customer list I wanted. So how do you find db.customer? Okay, it is simple, guys. Writing the JSON script is very simple. You get the lot of insight in the third module. I'm going to take 3 classes on the scripting itself. You get the full clarity on it. Don't worry. So now what I wanted to find is the people who belong to the OU colony under the customer. So you have to give the address first because it has 2 layers, right? Address dot means you are entering inside the embedded document. This is called embedded document. Why it is embedded document? A document you have this, the first document. Within the document you have another document that is called embedded document. A document within a document is called embedded document. When you wanted to read embedded document, first call the parent field and then call the child field. It's like that. So simple anyway. Street and colon and read what you wanted. Maybe I'm going with the OU colony, right? Whoever belong to OU colony, I just need it. And at the end, you wanted to read the data in a much organized way, just use this command. So see guys, you are reading the embedded document like this, giving the parent field name and the child field name and give the parameter what you want to read. So I'm giving this address.street. Even we have in the RDBMS also, if you wanted to read a table, first database, if remote means you are reading the data through link server, what do? You give the remote server name, remote server database, schema, table, and what you wanted to read out of that. So you're giving the complete address. The same thing here as well. Within the document, maybe you have nested embedded documents. Nested embedded documents may be like different case. Maybe you have the parent document, this is a child document, child to child document also. There could be more and more complex data they're entering. They might have the nested embedded documents. In that case, you address street has another child field, then dot another child field and give that value. It will go and read. So you have to just, it is like a tree structure. You are reading the data and reaching the data in this tree structure to get out of it exactly. So anyway, no need to worry. For now, we're talking about what is a document. We did not go for up to CRUD operation. CRUD operation will make you understand every script that we write. No need to worry, because I spent a lot of time there. So for now, a document means this: keeping the data locality in a single document. Keep, like if you are entering some record, that record data, all of its data should there in a one document only. If you are segregating the data into another document, there is no join in Mongo. So that is the reason, try to keep all of one entity data into one document itself. Don't segregate. Is it clear? Yes or no? Just introduction. I did not finish the document yet. We have a lot of discussion in that direction. Is this clear to all? Like what is document at least, and how we need to keep the data in the document? It's an idea. For now, it's
Yeah,
just an idea.
yeah, Ravinder, like supposing you can filter on a OU colony, right? If there are multiple records on based on that on the street,
Hmm.
so it
We
will
can get
display.
right one more. Let's insert one more as it is. So yeah, whatever it is matching, it will just get the data. So let me insert one more same record just for the sake of discussion. Now, if I go and read, OU, it will give it 2 records now. See, it is giving 2 records, first and second.
Okay.
Whatever is matching, it is giving all of that data. Clear? Clear, right?
So basically, the object ID is a unique one.
Yeah, of course. Should be, see, object ID, whatever is matching. This object is unique, of course. This is a unique one. This we are not touching it. This is a separate topic for us again.
Yeah. Okay.
This has a different meaning for us basically. It is giving you when you inserted the record. And also in a future classes, we can sort the data based on the time you entered. Like what is the latest document, what is the oldest document, we can identify using the object ID only. Basically, we'll see that in the future. How do we sort the data using this ID? The sort and grouping and everything will come in there is no grouping concept in Mongo. We have a lot of sorting methodologies. There I'm going to use all these fields and all. We will understand, no need worry. What are the business cases? How do we read the data in different ways? I'm going to talk about in the next module. This we are in the second module. Installation, just basic installations we are done. Now we are talking about comparing the Mongo with RDBMS, then architectures, Mongo architectures we are discussing. Then we'll enter into crude. Then slowly we'll enter into more and more detail of the product. No need to worry. I'll cover most of things that you need to know as a DBA. Even I include the development as well. So this is what is called a document, and this is how document has to be framed. All of the one entity data should be there under one document only. You cannot segregate because there is no join concept in Mongo, that you need to keep in mind. Right, let's come to the architectures. This is very important. Most of the interview questions are from this module especially. Most, without questions from this module, you don't have an interview, as simple as it is. First, your knowledge will be tested based on this architectures only. Try to follow as closer as you can. 2 classes I'll spend on this especially. Why? Because this is so important class to understand, so important concepts, because this is where you will get analyzed. What is story account, what kind of story accounts we have, what is architectures we have, how each story account deal the data, how the data recovery happen based on that storage engines. We have a lot of things, guys, in this module. Very important how Mongo recovers the data internally. The complete architecture discussed in this module only. We have multiple architectures in this. Basically, try to follow very closely. Right. So for today, I'm going to talk about only storage engines today. Multiple storage engines we have for the MongoDB, not one. Each storage engine has its own advantages and disadvantages. And what is the currently used storage engine? White Tiger. Everywhere White Tiger. We don't use in-memory. We don't use mmap. Basically, what are the major drawbacks about these storage engines? I'm going to talk about. Based on the storage engine, how data is loaded into Mongo will change in the background. Basically, what format data is. Format means binary bson format only, but how it is structured in the background, how effectively can read the data out of it based on the storage engine. Storage in a different layer in the MongoDB architecture. Basically, it plays very bigger role for the performance of the Mongo. So we're going to see all of that, guys. Okay, journaling is like a log file. Capital collection, TTL, and gridfs. Gridfs is the last topic. This one I'll pick it up after the backup restore, not now. But anyway, these 2 topics are important for us for this architecture. These are all concepts I have removed, I guess, from this module. I don't have this one. I should take out this one. These are all there in the future modules. We have, no need to worry. Okay, we have. I'm not removing, just no need to worry, because they are not architecture related. They are operations, indexes, and capital collections. That something comes in the schema design, all that. So now let's talk about the storage engine layer in MongoDB. Storage engine layer has a different architecture. Mongo log file has a different architecture, and overall logical is a different architecture. There is no consolidated architecture for Mongo. Storage engine has its own architecture. Mongo, like a log file have a different architecture. We're going to see all of that. No need to worry. Just try to follow as I'm discussing. You get the actual output of it. See, Mongo is compatible with any programming language, any product that you have in the market. It can be RDBMS, it can be NoSQL. Every product supports the JSON format data. That's a big advantage with the Mongo, especially because Mongo accepts the data in the JSON format. At the end, whatever, if it is SQL data or Oracle data, Postgre data, MySQL data in RDBMS, in NoSQL, Cassandra, Couchbase, Hadoop, whatever it is you are picking it up, in the end, you have to convert the data into JSON format. Then it will pick up the data into Mongo, basically. So to convert the data from different sources, you have different drivers. Basically, Mongo has lot of drivers it supports. Basically, if you see Mongo drivers, if you go and type, there are a lot of drivers are there for Mongo. Why? Because it can take the data from versatile platforms. Basically, let me show quickly once. MongoDB drivers. There are very big list for this. So if you go to here, so these are all drivers you have. So this is a programming language. It will name the drivers also. Just a minute. Java drivers. Go driver MongoDB GitHub. Just a minute. There will be drivers list. Vendor. No, not this one. Anyway, each programming, whatever you see, each program has its own driver to convert the data from that local language to the JSON format. If you install that driver and try to load the data from any language, that related language, you will convert the data and give it to the Mongo in the JSON format. So that is what is actually, at the end, you had to convert the data to Mongo query language. Basically, the Mongo queryable language is a BSON data or JSON data. It must come into from the external source. These are sources: content repo, IoT sensor backend, ad service, customer analytics, archive data, whatever you send. These are different types of data that you are sending into Mongo, and each one different application has its own programming language in the background. The programming, each different language has its own driver to convert the data into data locality. Like you are writing the data in C, C++, C Ash, Argo, Java, Node.js, PHP, whatever it is, whatever the program you write, but the related driver should be installed on the local machine. If that is installed, then it will convert the data to the local language automatically. MQL, Mongo query language, readable, understandable language. Once that is come into picture, then MongoDB data model, the storage engine will accept the data at the end. If the data in JSON or BSON format it is converted, data will be loaded into the Mongo. Once it is loaded, and again you have different architecture for each different story account. There are different story accounts we have. Data is converted, that is one story. Once it is converted, how data has to be stored, how it has to be processed, in which way, how effective, how badly, your dependent, your architectures are dependent. Based on that, we'll go to the storage engine. Everywhere White Tiger is a default storage engine. It is default, and it is not developed by Mongo. It is acquired storage engine. Someone developed it, they acquired it, they integrated with the Mongo. Now it is a proprietary to Mongo, but it is not Mongo developed storage engine. It is more effective with the Mongo. How it is effective, we're going to talk about each architecture, about each one. We have a lot of discussions on that one. And security, if you talk about how you are securing the Mongo, it is a different framework on the Mongo. Like you enable security and give the users name, user details and password, then only authenticate. That we will see. Management, creating databases, taking the database collection backup, database data backup, and restoring it and migrating it. All those comes under management basically. But security management is a different, included layers in the Mongo. But we are talking about data, not about the management right now. So let's talk about the storage engines one by one. Data can be any source, guys. As long as data can be convertible to JSON format, Mongo will take the data. As simple as it. And data types must be, it should be JSON format, CSV format. CSV format also you can push the data. We will see how many different types of data we can directly feed into Mongo. That 4 types of data we will see basically in the real time. CSV format, JSON array format, and what else? These are the main things basically. There should be some other data types, they'll call it as, I forgot that name. Okay, whatever it is. So generally you need to make the data into that format, and Mongo can take the data. How we can export the data to different formats, how we can import the data, that comes in the backup restore, not now. We are going to see that. First, how data can be handled in the underlying hardware structure, that is the main topic for us. Right, we have 3 types of storage engines. Storage engine plays very bigger role in terms of performance. Your performance is completely dependent on the storage engine only. These next 2 classes are theoretical, guys. After this, most of the classes are practical. But I had to complete through the theory because these are architecture. I don't have any option. You have to listen, you have to understand. Anyway. So the storage engine is the component of database that is responsible for managing how data is stored both in memory and disk. So based on the storage engine you choose, the processing of the data or loading of the data will change. How it is changed, how it is going to impact the performance, we'll see that. First, the most famous and everybody 99% implemented engine storage engines are White Tiger basically. White Tiger is a default storage engine starting from 3.2 basically. White Tiger is a default engine. White Tiger is introduced. We discussed about Mongo versions, guys. 1.0, 1.2, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.4, 2.6, 3.0. We discussed all of the Mongo versions, right? What are the versions we have? So 3.0 has the White Tiger introduced, but it is not default. When you install, see if you wanted to check what is the storage engine for Mongo, open a new session, just we can check it out quickly. What is the default storage engine for Mongo? How do we know? So cd var Mongo log, it will write in the log, and even here in the Mongo also you can find it. db.server status storage, we have that storage. Let's see this, so it will maintain everything basically. If not, I'll go the different way, right? Storage engine, what is the server? This is one of the biggest helpful function in the Mongo. It will hold lot of details basically, if just for the sake of discussion. So if you see server status, how many connections are there on the Mongo, how many people are connected at the moment, how many active connections are there in the Mongo, you just type this command connections. It will tell you two connections are connected and total only one connection is active right now, and total available connections are 817 at the moment. 817 connections can connect. If you want to increase, we'll see. So this one is going to give you lot of health of the Mongo, how memory utilization, how many connections are there, how many blockings are there on the Mongo, and how many inserts are going on at the moment, how many inserts are already happened in the past on the particular database, particular system. We can track lot of information from this function. Especially this will help in many directions for our troubleshooting. I'm going to talk separately on this one a lot of time, maybe 20 minutes, more than 20 minutes. What are the main parameters we will read out from that function to troubleshoot the Mongo basically. This will hold all of the troubleshooting information in some way, like it doesn't have everything, but what is going on in the Mongo right now, just to get to know. If corruption happened, we cannot find here, but why? Because Mongo will shut down. Where we find basically in the log file, in the Mongo log file. How do we read the Mongo log file? How do we exactly pinpoint one particular point? We will see today itself. No need to worry. It will come with a class by class. Will gain the knowledge. No need to worry. Now, what is the default engine for storage MongoDB? Is a White Tiger. We just verified. You see that White Tiger is a storage engine, right? We've seen. So from 3.0, White Tiger is introduced. 3.0, we discussed the versions, guys. 1.0 to 3.0, there are many other versions in between. But storage engine is introduced in 3.0 only. Before that, you don't have it. No one is running 3.0 lower versions in the market right now. They are completely unsupported and out of legacy technologies, legacy versions now. No one is using. So I said, what are the three versions we have in the market now? 3.6, 4.0, 4.2. These are the stable versions are running in the market. They have the Mongo support. 3.6, 4.0, 4.2. I discussed these points on the website, if you guys remember, in the last class. So from 3.0, MongoDB uses a White Tiger. But from 3.2, default is a White Tiger. You don't need to mention. If it is 3.0, you had to explicitly mention the parameter in the config file. I wanted the White Tiger in 3.0. If it is 3.2, then you don't need to mention. By default, it is White Tiger itself. So how you can claim the storage engine in the config file? We have a discussion on that one. You can add it if you wanted. You don't need to add from 3.2. So no one is in the market is running the lesser than 3.2. I don't think, because it's completely out of support model. If they are using it mmap v1, we're going to see what are the disadvantages also slowly. Just keep in mind what is a White Tiger, where the White Tiger, in which version White Tiger is introduced. 3.0. This is an interview question. It is definitely asked question. And from which version storage engine, White Tiger storage engine is default 3.2. These two, either of this question will be mandatory, will be asked in the interview. Default, like storage engine version, or else introduced to MongoDB the storage engine version. White Tiger storage engine introduced in which version? 3.0. This came up. Right. It is well suited for most workloads and recommended for new deployments. White Tiger provides a document level concurrency, checkpointing, and compression among the features. So let me see. When I go to the next slide, I'm going to explain about what is the concurrency it is going to give, what is the concurrency this is going to give, what is the concurrency this is going to give. All will be discussed. Okay, just a minute. Someone is hitting the bell. Just a minute. Oh, sorry guys, don't mind. So now the default storage engine is White Tiger nowadays. Everyone will use the White Tiger only because it has lot of advantages over the other storage engines. Anyway, what are the advantages? We will pick up in the next slide only. So White Tiger will give you the more concurrency of transactions on a single document. Single document basically. We will talk about document level transactions only. Ultimately, every transaction is independent to document. One transaction cannot hit the two documents. Sorry, two collections. One transaction cannot hit two collections. Only one collection, because there is no join. There is no chance of hitting one single transaction go on hitting the two different collections. Only one. And one is how one collection can go with the different how it can give the concurrency of concurrence at collection level, that we will see in the architecture part in the next slide. But for now, White Tiger will give the more concurrency than the MRV1, as simple as it is. How it is going to give, we'll see. And checkpoint and compression. See, White Tiger MRV1, there is no compressor. Compressor means compressing the data. What kind of compressions we have in the White Tiger MFV1? Basically, White Tiger, see, MFV1 does not compress the data in the background. White Tiger will compress the data using the snappy compressor. There is something called compressor by default given to the Mongo for the storage engine. If it is a White Tiger, you will have the snappy compressor by default. MFV1 does not support the compression in the background. Your data will be, for example, if I'm loading 100 GB data, 100 GB data will load as it is, 100 GB. It will occupy 100 GB hard disk. If I load with White Tiger 100 GB data, you will see only 3 or 4 GB data. Actual data, what it is going to show, see, when I go and see, show DBs. It is going to give each database size. It is giving at the moment, if it at least has to have 1 MB. 1 MB will give 0.001 MB, basically, GB. 0.001 GB is equivalent to 1 MB. So if it is at least 1 MB, it will give some value. 1 MB is equivalent to can be 90%, 90 MB. One equivalent to actually in the background, it is already compressed data. If you take 1 GB data, it can generate a very big file as a backup file when it is pulling it out of it. So let me show you this better. I mean, I'll come to this one, don't worry. There is a compressor for White Tiger. There is no compressor for the MRV1. And this is how it is going to compress. And let's see in the website, guys, better. I'm just giving an idea. I did not finishing anything today. Tomorrow I'll finish the Sora engines, but today you get the fair idea what is Sora engine, White Tiger, MAP, and in memory, at least an idea. Okay, I give it here, right? Snappy compression, glib compression, right? So MongoDB supports two compressors basically. One is a snappy compression, and two is a glib compression. So basically, glib we don't use it. It is very rigorous in terms of compression, but it is going to create a lot of performance. So let me show this. Okay, this is the right one I'm looking at exactly. I'll show you this. You get the fair idea if you understand this, right? If you see guys, this compression types will be supported by storage engine White Tiger only. There is no compression with other storage engines. If it is just White Tiger, what happens? And based on the compressed, uncompressed 5 GB data, this is the data you see in the hard disk. This is the data 5019 MB, including headers and system information. Everything will include in the file, so it will become 519 MB. If it is a snappy compressor, 5 GB data is converted into 254 MB because it's compressed. Actual background data is 5 GB, but what you see in the show DB basically 254 MB only. Why? Because it is compressed. There is a glib, It's a very dangerous compression. 5 GB will become 19.26 MB GB. If you see, this is a 5 GB, and you see the smallest bar, it compressed this big bar of data to this small bar. So it is compressed very rigorously. And if you see 95% plus, maybe the percentage wise, if you look at, did they give it any percentage? How percentage? They did not. Anyway, fine. So if you see the compression, guys, compression also depends on the data you are loading. If it is a plain text data, it will compress as expected. 5 GB will become 254, roughly 250, maybe 300 MB. 5 GB data will be compressed to 300 MB by default compressor. If you're loading a videos, PDF, which is won't compress a lot, depends on the data you are loading. The compression ratio also will change. It is not constant. You try to follow this, guys. Very important point. So in the white tiger, there is a point it is talking about. What it is talking about is provides document level concurrency model, checkpointing, and compression. This is what I'm talking at the moment. Compression. There is no MapV1 is the original MongoDB storage engine. It is default storage engine for Mongo up to 3.0. It performs on workloads with the high volumes of reads and writes, and as well as in place upgrades. So it is actually writing the data as it is. If you have 100 GB, it will occupy the 100 GB. It reads the quickly data. It will write data quickly and reads data quickly. Why? Because in the background, it is not taking the load and the compression. It's just writing as it is. So it is not going to save the money, especially. Why? Because MongoDB handles with large volumes of data. If you are keeping all the data as it is, you need more and more hard disk to keep the data, and the IO also will come down, and memory also you have to load a lot of memory. Why? Because if you want it to read as it is, it takes input output operation impact as well as storage both. So here compressor is going to do a lot of big job for us in terms of performance. IO performance is very important for us. So the snappy compressor 5 GB data is directly converted to 254 MB. It is ideal. It is not fixed. Don't keep it as a fixed. It is ideal value. If it is a plain text data, this is going to happen. If it is not a plain text data, it is roughly 90% is compressing. This is up to 97, 98% is compressing. So compression ratio percentage depends on the data you're loading. It can be videos, PDFs, which non-editable data won't compress well. See, if you compress the text data, even normal glib or anything you compress, text data will compress a lot. If you try to compress the video, it won't compress much. Why? Because there is no scope to compress much. So that is how the Mongo also depends on the data you are inputting to Mongo. The compression conversion will matter. Following or not following? Please say something. Don't keep quiet. I need an answer. You guys are following what I'm trying to say?
Yes, so Ravinder, so for the compression on the white tiger, how does the performance work? So based on the other one.
Right. If you see, there is no compression in the MapV1. MapV1 will give you the good performance than the white tiger in terms of reads and in terms of writes, basically. In terms of writes, why? Because reads anyway, it won't give you the performance. Why it won't give the performance? It is going to impact your IO. Why? Because you are making 100 GB, you are reading 100 GB if you are reading. If it is a compressed, maybe snappy compressor, you are using 100 GB roughly, you might use 2 or 3 GB. So reading the 2 or 3 GB data is easy for the system. So reads will be slower here anyway, writes will be faster. Here writes will be slower. Why? Because it's converting the data, whatever it is converting, compressing and writing it will be slower, but reads are faster. And not only reads you're talking about, you are saving a lot of storage in the background. Why? Because you're occupying less storage, less data, and management will become also taking the backups and all that. There are a lot of things are dependent in the background again. So we need to take a look at the majority of the advantage, not the lesser.
Okay.
Following?
Yeah.
Right. Let's go to and check what storage engine it is, what compressor it has basically. Let's see. Does it have in the server function? I'm not sure. It will hold everything server information, but compressor do we have here? Let me see. No compressor. Okay, in the log file. It'll write in the log file if it is not here. I'll show you what compressor it is using. Log. In the Mongo, this is a log directory. You see this? and cat Mongo. It is going to read entire file. Oh, come on. I need to. So how many lines I have? How do I know? See, this is equivalent to 22 KB data. This is by default bytes. So how much of data I have in that file? How do I know? We discussed WCL and Mongo. How many lines of code data is there? Come on, sorry guys, I need to use sudo. We discussed all of this sudo, why we need sudo and all permissions. 167 lines we have, so which is fine. I can directly read it, comfortable. 167 line of file is not a big file. Cat sudo must use it because I'm not the owner of the file. So this is what it is. The complete Mongo file writes a lot of events. I'm going to talk about this separately anyway. There's something called compressor. Do you see any compressor? Something kind of parameter. You must see it anyway somewhere. This is where it started. Right, you see this compressor, snappy compressor. By default, White Tiger will use the snappy compressor. You don't need to mention. If you wanted to change the compressor, you have to use the extra parameter in the config file. Like I wanted the glib for some reason. You're just loading the data, but you're not at all reading the data at all out of it. Then go for the glib. Glib is something is more rigorous in terms of compression. So more compression, more load on the system when you're reading and writing both. Why? Because it has to decompress and give you the data. So we don't use that. It is giving more compression, but it is adding the more computing power also. So by default, we'll keep the snappy compressor only. It will come by default. You don't need to apply it. You don't need to enable it. By default, it will come up. glib is something more rigorous in terms of compression, but it is going to have extra load in the system. This is something is balancing everything, compression ratio as well as storage benefits both. That is why this is recommended. Snappy compressor is recommended on the Mongo to keep the data minimal as well as a good performance, and the maintenance also will be easy in both the direction. It is in the middle, right? Compressed, more compressed and middle compressed kind of. Use this snappy, anyway you'll have it. So maybe if it is you have lot of data, you are not finding it. So I wanted to read if the compressor snappy is there or not. How do I find in the file? I'm reading we discussed this point already, if you guys remember. Sudo cat mongo log. I can grep it. Grep what I wanted, what I'm looking for. Compressor. So it has a compressor called snappy. We discussed these commands. You guys remember? Find, grep. I discussed with a lot of examples. This is one of the good example. You understand? I said like I'll call these commands in the further classes as well. So when the data is large volume of data is there in the log file, you're not able to find what you're trying to find. Use these commands. Read everything, but grep it. So do you get what you wanted? Following? This I discussed these commands. You guys remember? Yes or no?
Yes.
These are all important. The basics, again, you have to go back to the basic and clear it out. Okay. If you don't know that command, because we discussed. Anyway, so White Tiger is giving the lot of benefits than the mmap v1. Concurrency, anyway, I'm going to talk about this in the next slide. This is very, very important slide. From this slide, there will be many questions in the interview, many questions, not one. Because this slide, if you understand, if you want to understand, you need to understand the architecture. And you will come to discuss the architecture first, then come to this slide. Let's finish this, guys. In-memory storage engine, these two are covered just as an introduction. We have one by one again, I'll cover up. In-memory storage engine available in MongoDB Enterprise only, not in the community edition. We don't have the in-memory. I never seen nobody's using the in-memory storage engine. It's very costly for the environment to manage it. How it is costly, I'm going to explain it. In-memory storage engine. If you wanted to understand the in-memory, quickly recap of it. Just you got an idea what is mmap v1, what is White Tiger, like that. mmap v1 does not give you any special features except keeping the data as it is and reading the data as it is, giving you good performance. Why? Because it is not compressing it. And one more bad thing with this is concurrency. There is no concurrency, zero concurrency with this mmap v1. Zero means what is zero? I'm going to talk about in that particular only. What is in memory? In memory is something you are running the server. Okay, you have 1 TB data. This is data, assume a case. Just keep in mind, try to understand architecture. Then I'll enter into the slides anyway. And you have 1 TB data. 1 TB data, which means you need 1 TB RAM. There is no disk concept here. You don't write the data at all in the disk, everything in the memory. That is why it is called in memory. People are writing everything in the memory. If the system is rebooted, all data is gone. Then how you handle? You cannot handle in-memory architecture with one machine. You have to come up with a different architecture. Then only this can be implemented. How it can be implemented? Quick understanding. So you need to have a replica set. It is mandatory to keep a replica set. How you can manage this? Let me explain this. We did the R&D, but our client did not approve for this. Why? Because the cost is very high to manage this in-memory storage engine. It is simple anyway. You have to just mention one tag is a storage engine in memory from the kind of thing. It will utilize all of your RAM automatically. Why? Because it does not keep the data on the disk. It does not write the data on the disk. It always keep the data in the memory. When the system is rebooted, memory lost, data lost. How we can recover? There is a different architecture to recover. So let me quickly talk about this. Not too much of time. Just a minute. Sorry guys. See, if I have 1 TB data, 1 TB RAM I need it because there is no disk involvement at all. Everything is in the memory. Read, write, everything is going in the memory. But if the system reboots, your memory is lost. Then your data is lost. So you keep one more standby in memory replica machine. So whatever you're writing here, it is writing to the other machine memory automatically. Okay, 1 TB RAM here, 1 TB RAM here. It's necessary. It is mandatory. How much data you have, that much RAM you need it. As simple as it is. So if this goes down for some reason, rebooted, automatically the role will be changed here. Data is in the memory again. You get the same good performance from that machine also. If this is also lost, if this is also down, these both are down, you lost the data. That is the reason we will keep here data in the disk in the third node. All the data will write into disk. So whatever you do here, it is writing to here as well. Here in the disk. Okay, this architecture is mandatory to follow the storage engine. Without this, you cannot use the storage engine, as simple as it is. So whatever you write here, it is writing into this memory and it is writing to disk as well parallelly. If this goes down, what happens? This will pick up the load automatically. People don't see the performance impact at all. If this is also down, see, two nodes are down is a worst case. One is down, you have to immediately pick up the as a bridge and then working on it or something. You have to make it up online. Such a critical products people run on the in memory. So now, if this is also lost, you need to have some fail safe, right, for your data. This is on the disk. If both are down, still it will operate with this one with the arbiter support. There's something called, we'll see that further anyway. So minimum 3 servers you need to have to maintain the in memory. It is mandatory. Without this implementation, you cannot go the in memory store engine at all. To maintain 1 TB data, you need 1 TB RAM in two machines. Here also you need roughly 300 to 400 GB RAM minimum to maintain that data. MongoDB is a more memory intensive product. Even in the disk also, the ratio, I'll talk about the memory management in the performance tuning. How much memory you have to give it to based on the data present on the Mongo. What ratios we need, what sort of data they're reading. I'm going to talk about that in the performance tuning. We have a performance tuning. We're going to talk about how do we trace the long running queries, how do we see the execution plans, how do we recommend the indexes. It is very easy in Mongo. Very simple. I'm going to talk about that in the performance tuning, in detail performance tuning. Don't worry. For now, if you wanted to maintain 1 TB data in the in-memory storage engine, if you wanted to maintain, this is a minimum architecture you need. No one is offered to keep 1 TB data with a 2.4 TB RAM you wanted. Minimum. It's a huge cost to the client. Memory RAM is not cheap, right? You have to invest a lot, basically. So it is definitely impact to the see, you are investing more on the IT infrastructure, you are losing your money from the business, right? So people are not interested to invest this much of amount because data is very rigorous. 1 TB will become 2 TB, 2 TB, all immediately had to upgrade to 2 TB RAM here automatically. So the maintenance cost will become more and more. Maintenance means infrastructure cost, not maintenance. Infrastructure cost will become more and more. So we just tested, guys. In the initial phase itself, we stopped. Why? Because of the cost involved in this architecture. So you guys understood this, what I'm trying to say here? Got an idea what is in-memory storage engine means? How it required? Just an idea. You don't implement, you don't see this in practical. Why? Because this is not possible. The lesser VMs basically. Definitely see what is you need to add one extra parameter to enable this. That's it. It will keep the data, all of your data in the memory itself. No disk is involvement is required except the log file. Data directory is not going to the memory itself basically. But here, this is not ideal solution for the most of the businesses at all. So you go for the white tiger only all the time. But got an idea on this one? What is in-memory storage at least? How it is implemented? Say something, by please don't keep it. If you keep it quiet, I don't understand like whether you are following or not following, right? Just followed, right? Everyone.
Yes, yes, I got it.
Yeah, thanks for the response. Right. Let's move to here, guys. Let's move to the next slide. So these are the rough idea. You got it. What is mmap1? What is a white tiger? What is a in-memory storage engine? See, in-memory storage engine available in only enterprise. Rather than storing the documents on disk, it retains them in memory for more predictable data latencies. Like you get the quickest response, the best response time, but there is a lot of investment you have to do in the infrastructure. Right, let's talk about one by one now. We got just introduction. Let's talk about this. White Tiger Storage Engine. White Tiger Storage Engine uses a document level concurrency control for write operations. Basically, what exactly it means? Let me explain again. That single word has a lot of meaning in it. See, you have a collection. Okay, collection has a documents like this. Come on. This is important point. I'm going to close almost architectures tomorrow. Just have an idea today. Like this. Maybe I don't need to do again and again. Come on. Copy paste. Right. See, assume a case you have here 1,000 documents. 1,000 documents. It is a collection. What we are seeing is a rack kind of thing is a collection. Collection can have the documents. Now, if it is mmap v1, first one by one. If it is a mmap v1 storage engine, you are reading from the application. This is an application app. Now you are writing something on the collection. And the collection, you are trying to update only these two records. Just assume a case, updating two records in a condition. If you are updating collection of two records only, entire collection will be locked. Complete collection will be locked. Only one operation is allowed. Only one operation is allowed. Write operation allowed at a time. One collection. Only one write operation. So you are writing only. You are trying to modify only two documents out of this complete collection. That two documents modification is holding the lock at collection level, so no one can write at that moment. All will go into the queue waiting stage. How many sessions are waiting, how many under execution right now, we can see in the Mongo clearly. It will show you here quickly if you wanted to see this. There is something called db.server status. Come on, I'll try to correlate this output. What was that actually? Let me read this. It is a very big output. I'm going to tell you what is important out of this output. Memory. This is a memory utilization. I'm going to talk about this. Come on, there is something I wanted to read. I forgot that parameter. Not this transaction security. No, right. This one op counters. Right. This is op counter. And if you see op counter replication, normal op counters, total these many transactions have been made, and op counter latencies, and right, this is where right op counters and replication. Where is this gone actually? there is something called active transactions and waiting transactions. All we can see available linear. Come on, right? Global locks. There is something called global locks. Right. This is what exactly. This is what I was looking for. Right. Sorry guys, I forgot about that parameter especially. Locks. Who are waiting? Who are doing the actions? Right. Global lock. Is it the same? What was that? Global locks. You must match that parameter, else it won't give you the output.
It's like only
I'm
one.
in global lock or global locks. Just a minute. I'll copy it. I don't want to type then. Not to waste time. This is enough. Shift insert. Right. Let me explain this output. See, total. How many are there on the system right now? Basically, okay. Total transactions are waiting for the lock. This is something current queue. Total. How many readers are waiting for the lock? How many writers are waiting lock? These are blocked transactions. These are blocked. These many people readers are blocked. These many writers are blocked. How many actively reading it? How many actively writing it? Total active connections, including system also. But how many are reading actively? How many are actually writing it? Because of these people action, these people are queued out. Why? Because they are holding the lock. This is the information we'll get it from here. So now, if it is mmap v1 storage architecture, if you're trying to modify two documents of a collection, it will log the entire collection. It does not give you any concurrency. If it is in place of it is a storage engine like White Tiger is a document level concurrency model. Document level concurrency model means if I'm trying to modify a collection only this segment of this collection, what does it do? It take the snapshot of this documents into memory and modify it and apply back. So when I'm updating these three rows, these three documents only locked. Other documents are open for the other operations. Maybe someone else wanted to modify these documents with another query, then I absolutely open to do it. So what it is does every time, it will pick up this snapshot again into the memory snapshot and lock these three documents for that write operation. It is only locking the segment where it is trying to update or whatever it is going to delete. Only update and delete create the lock. Insert does not create the lock. It will keep inserting the data at the end of the file. Okay. Delete and update will create the lock. Read also will impose a read lock that we will see. We can override the lock if you want it, if the different operations. But right now, how data will be handled in the background with the different storage engine that you need to understand. If it is mmap v1, it is a collection level lock for every update and delete operation, or even select also. If it is storage engine White Tiger, it is something like what segment you are reading out of the collection, that segment will be locked. Other segment will be open for the other transactions. So that is where you get the more concurrency on the documents. And a single collection, I'm example modifying one document, I can modify. Other segment, other people are modifying. Other segment, other people are. So concurrently, these modifications are going in a single collection at the same time. It is a huge advantage to the business. Why? Because only this one particular segment is locked, and this segment again, once it is written and checkpoint right into back, and this segment will be released again for the other operations. So this kind of architecture, this is very important understanding. If you don't understand, please ask your question, because I'm going to refer this again and again, but I'm not going to tell you with the diagram. With a White Tiger storage engine, we have a concurrency level within the collection. Like we can lock only one segment of the collection, what is it is about to update, not all. If it is mmap1, it doesn't matter what you are updating. It does not look for the range. It just locks the entire collection. Following or not following? Say something, please. This is very important point.
Yeah,
If you don't understand,
following, but have a question like in these weird collections, we need to have a very large memory.
Of course, White Tiger, you need a large memory, and based on the data, how much memory we wanted, I'm going to recommend that. I'm going to tell the recommendation, the performance tuning. That comes in the different story. First, understand the architecture. Memory part will see separate.
Mm-hmm.
It's something we are talking about what you can do with the each storage engine. Performance, memory management, and memory recommendations we'll see separately. But understand the underlying architecture of the data handling. That is important for us. Understood, right? The basic
Ravi,
difference between. Yeah.
Ravi, one quick question. So, for example, I'm deleting if this particular single collection having around 1 TB of data. So, if I need to delete any particular line, so the log will be applicable on all the complete collection. So, is it right, or
No, if you have maybe you have 1 billion
it's like a
records.
page? Mhm.
1 billion records. You are trying to delete 1 million records. Only 1 million records are locked for the delete. Other 99 millions are actually open for the operations. It's like that.
Okay, in the collection level. Okay.
In that collection. So only you are locking in which segment of data you are actually required for that condition. It is condition based. That is what is called concurrency at document level. How checkpoint works in Mongo. Checkpoint is next slide. Next slide. We have the topic. Just try to understand the architecture first, then we'll go to checkpoint. We have a detailed discussion in the checkpoint. I'll pick up that tomorrow. You don't understand in 10 minutes check what is checkpoint, how it is going to work. Checkpoint will build log files. Log file, it will be recycled automatically. There is a huge discussion tomorrow. I'll come with the, I'll show you the practical, how in the background things are working. I'm going to show practically so that you understand more connected. 10-minute checkpoint cannot be explained or finished, but we are talking about the storage. Checkpoint is about where I was talking about the checkpoint. There is a checkpoint discussion here. We have the checkpointing. Checkpointing is talking about in this slide itself. Somewhere I mentioned. Right here itself, in this line itself, we have a checkpoint. Each line will take a lot of time to make you understand, right? So we are on these two lines. I'll finish for now before the class. White Tiger uses the document level concurrency control for write operations. Document level means you have 100 documents in a single collection. You are modifying 10 documents. 10 documents only will be locked. Other 90 documents are open for all other operations. Read, write, whatever you want to do, delete anything. That is called document level concurrency for the storage engine. White Tiger uses a multi-version concurrency control. What is a multi-version concurrency control means? It is taking the copy of the version of the collection, this particular segment collection, into the memory and doing the modification, applying back. Once it is applied, it releases the lock on that segment also. That segment again open for the other upcoming transactions. So it is picking the version. This is one version of data, this is another version of data, this is another version of data. Multi-version concurrent control. It is taking in a single collection, each segment copy it is taking and loading in memory and doing the transaction. That is called multi-version concurrently control. It is not updating data directly in the collection. It is taking that data into memory, applying, and then giving the data back to the data file. It's like that. That is called multi-version concurrency control. At the start of the operation, White Tiger provides the point-in-time snapshot of the data to the transaction. Snapshot presents consistent view of the in-memory data. See, one thing, guys, you just need to understand this snapshot. What is snapshot? If you see, this data is a snapshot. It is snapshot means it is taking copy of it. Snapshot means what? Copy of that data, taking into memory and writing into back to the data. It will make the data consistent at any point of time. Why it is actually keeping a lock? To no one should come and make the data change at that moment. If you are unlocking this particular segment again to someone, data will go to inconsistent. Every snapshot is responsible on its own to make the data consistent in the background and give the lock to someone. That is a terms you have to use. Following or not following? Say something, please. Don't keep it quiet. This is important point. If you keep quiet, you're keeping yourself a question. Each segment of a data is a snapshot. Taking the memory into a snapshot, we'll call it as snapshot or version. Snapshot or version. Snapshot is the most used word. We're taking the snapshot. this snapshot is responsible to keep a lock on this segment till it is written back to the segment to release the back, so that data will be consistent. So whatever I written, that is a final. If someone is also taking the lock, if the snapshot is allowing the lock from the other session, it can modify intermittently. This also can what is the end status of the data, that will be inconsistent. It will form the inconsistent data, so that should not happen. The snapshot is responsible to log the segment what is it is picked up into the memory, and once it is done, it will apply back to the that segment and leave the lock. Is it clear? Please say something. Don't keep.
Yeah. Yes, sir.
Yeah, thanks guys. I need the response, like, if I'm not teaching myself, you need to understand, so then only I can progress with confidence. So this sentence, whole sentence is that basically the snapshot will take care of the in the background to keep the data in the consistent way, so that no one will interfere in that segment what the snapshot is locked. Basically, checkpoint, this point will make a very big point, especially when writing to the disk. White Tiger writes all data into snapshot in a snapshot to disk in a consistent way across all data files. If it is a sharding, data can sit into multiple drives across all files. Means if data is divided already, you're trying to pick up the data from multiple systems, that segment, then multiple files will be locked, multiple files will be updated at the same time. If it is a sharding, if it is standalone, only one file will be updated. What you are configured, based on that it happens. It is writing the data to multiple disk because it is a sharded. If not sharded, one. Okay, it is like that. That point means that basically. Now durable data act like a checkpoint in the data file. What is checkpoint? Is this point is going to make you understand. The checkpoint ensures that data files are consistent up to and including the last checkpoint. How many records in one doc? Just a minute, yes, there is a question. How many records in one segment? There is no records. I mean, how many records doc in one segment? What is that question? In one document or one segment? What do you mean? Guru, can you clear it out, this question? You can speak, right? See, record is a document. Record is a document. Okay, segment means what is a portion of how many number of documents you are locking, that is a segment I'm calling. See, three documents. You can say these three are the documents, and I'm trying to update three documents, which means this is a segment for updating it. Is it clear, Guru? Okay, that is what it is. So I covered only the major part is, guys, storage engine types. Okay, don't worry about it. Tomorrow I'll go in more in detail. Why? Because in a one class this cannot be finished. So what you need to understand today, you have three storage engines in Mongo: White Tiger, mmap v1, and in memory. White Tiger has a compressor. It can give you a lot of data saving, and mmap v1 does not have a compressor. It writes the data as it is. And mmap v1 does not give you the concurrency control on the collection, whereas White Tiger will give you the document level concurrency control using the multi-version concurrency control. There is MEVCC. Okay, these 2 points are very important. And if it is if the collection is sharded, wherever the data in the multi-concurrency control is touched, all the data will be written back to all of the files. That is what this statement is saying. Okay, so I'll pick up this point tomorrow, and I'll complete this architecture. I'll pick up this architecture, this and this, and then come to the slides. If you understand the architecture, you understand the slides. So I'll show the architecture, I'll show in practical and what is happening in the background. Then come to the slides, you get the full clarity on it. So mostly 90% of the architectures will be finished tomorrow, maybe if not day after tomorrow. But these are all very important discussions. Without this module understanding, you cannot track the interview. Storage engines are very important. We'll see that. So that's all for today. Any questions anyone want to make before I stop the recording? Anything that you have in your mind?
Could you
Yeah, go
please
ahead.
send me this what is this PowerPoint?
What? Can you come again, Anita?
Okay, for this PowerPoint slides that you have, this Module 2
Uh,
session PowerPoint, yeah.
You want about the slides actually?
Yeah, no, this PowerPoint file itself, what you're displaying right now, that one.